There is no limit to inquisitive mind and perfection of knowledge. The Infinite Science program focuses on the latest scientific achievements, new developments, and unique discoveries by Kazakh scientists. Infinite Science is an opportunity to see the future of science.
Biochemists from California and Western Australia have managed to do the impossible. They have unboiled a hard-boiled egg, returning it to its initial liquid state. In the language of science, what happened was the reversal of the process of denaturation of protein, or renaturation. Today, this quick and cheap technology of protein renaturation can be used in the production of pharmaceutical drugs. Hello, my name is Yerkebulanbek Muhanbet, and you're watching Infinite Science. In today's episode, nuclear medicine, the use of radioisotopes in the treatment of oncological diseases. The need for creating new isotopes, thereby expanding the array of these radiopharmaceuticals. Achievements of Kazakhstani chemists, nano-catalysts. A cluster or a small so-called colony of a set number of atoms or molecules. Agriculture of the future. Why are scientists studying sorghum? The potential of this crop culture to generate high and stable crop yields. According to the data of the World Health Organization, the cancer incidence rates in the next few years will be getting higher. By 2030, the number of patients with oncological diseases is predicted to rise by 70%. About 20 million people annually will be diagnosed with cancer, and the number of deaths from malignant tumors will reach 13 million. This is precisely why the methods of diagnosis and treatment of cancer remain being one of the most pertinent tasks of contemporary medicine. When traditional medicine is powerless in the face of oncological diseases, nuclear medicine comes to aid. This field of study involves the application of radioactive substances in the diagnosis and treatment of cancerous tumors. However, in this case, the term radioactive should not be a cause for concern. Medically used isotopes have a short half-life, and therefore the patient is exposed to radioactivity for only a short period of time, from a couple of hours to a couple of days. With the use of this method, it is possible to detect cancer at an early stage without exposing the patient or those around them to any risk. Therefore, we administer this radiopharmaceutical into the human body and then track it with a gamma camera, and thus are able to trace with high accuracy the epicenter of the tumor and then begin its treatment. The isotope that is most widely used in nuclear medicine is technetium-99m. The intensity of its radioactivity in the human organs is the foundation for the diagnosis of many diseases, including oncological ones. However, the search for more efficient isotopes continues. At the Institute of Nuclear Physics of Kazakhstan, scientists are working on the creation of new pharmaceuticals that are safer and more effective. It is necessary to create new isotopes and expand their array of available radiopharmaceuticals. Across the world, there are more than 50 known radiopharmaceuticals. In order to raise the diagnostic efficiency of treatments, each organ of the human body requires its own unique radioisotope prescription. For example, a healthy cardiac muscle accumulates thallium-201, while the thyroid gland accumulates yodium-123. We are already working with technetium and yodium-131 and would like to create new pharmaceuticals with the use of thallium and yodium-123, which has a lower radiant energy and hence lower radiation dose. In the near future, a diagnostic and treatment center will start operating under the Institute of Nuclear Physics, which will be able to offer qualified and high-tech treatment to a large number of patients.
Каталитические реакции играют огромную роль в нашей жизни. Ферменты или так
Catalysis plays a huge role in our lives. Enzymes, or so-called biocatalysts, are active agents in the regulation of vital processes in our body. Production of necessary industrial chemistry products is also done with the aid of catalysis. About 90% of the volume of chemical production is based on this process. There isn't a single modern chemical manufacturing process that can be done without the use of catalysts. However, these reaction-accelerating enzymes are not part of the list of products produced by the chemical industry. Today, in order to develop catalysts, chemists turn to nanotechnologies. Hence, only an extremely small concentration of substances is used. We're talking about a cluster or small so-called colony of a set number of molecules and atoms. This promising line of research is also being taken on in Kazakhstan. Scientists at the Kazakh national universities have developed their own technology for the development of multi-purpose nano-catalysts. First of all, the process of manufacturing is not complex. Second of all, it is ecologically harmless. And thirdly, of course, the most important aspect is that financially it should be much cheaper than previously used methods. So what is the foundational methodology? Scientists use a so-called sandwich method, or layer-like placement of the molecules of catalyst substances. A specially prepared glass sheet is used in the process. A number of layers of a polymer matrix are first formed on this sheet. Then scientists infuse the most active substances. A set methodology was of course developed by us. On the basis of this, these first catalysts were manufactured. The first nano-catalysts are used for the oxidation of toluene. This substance is used as a base for the production of a large number of other substances. Cations of copper and nickel serve as catalysts in the reaction with toluene. Their layer-like positioning on the glass sheet result in the multi-purpose character of nano-catalysts. The surface layer of the metal can wash off over time. However, there is another layer of metal and another. Today, this field of research is at an experimental stage. In the future, scientists are hoping to develop multi-purpose nano-catalysts that would be used in other chemical processes. According to archaeologists, the historical beginnings of farming agriculture go back more than 13,000 years. It was when the hunter-gatherers began planting collected seeds of wild plants, such as barley, smut, rice, corn, and wheat. Since then, hundreds of other plant cultures appeared, which are today competing for the role of the most promising ones. Today, on our planet, we are experiencing a global climate change. It is accompanied by rising temperature levels and higher drought rates. Due to this, scientists all across the world are studying plant cultures that would be productive in the new environmental conditions. In Kazakhstan, this task is taken on by the Institute of Plant Biology and Biotechnology. Here, specialists are working with a special crop culture called sweet sorghum, which, according to scientists, is quite different from other crop cultures in terms of cost efficiency. It differs in terms of its resistance to extreme weather conditions, drought, salinification, and other unfavorable environmental factors. This crop is able to generate high and stable harvest yields. Another special characteristic of this crop is its wide applicability. Sorghum syrup is a source of sugar and bioethanol. The seeds are used in the feed of birds and fish, and its bio-waste can be used in the production of solid fuel blocks and even paper. That is why Kazakhstani scientists are proposing to establish waste-free production of this universal crop in the country. Today, the main tasks of the scientists is to make the cultivation of sorghum on the territory of Kazakhstan possible. In order to make this happen, for already more than 6 years, they've been gathering samples of this crop culture. From the collected samples, we will be selecting the most promising forms for cultivation in our environmental conditions. In the future, scientists are planning to join efforts with specialists from other institutes in order for the cultivation of this crop to reach industry-wide scale of production. Following up on this topic and mentioning some of the themes from our next episodes, plants and crops, like any living organisms, are prone to viruses and diseases. Therefore, the preservation and quality of collected harvests directly depends on the phytosanitary conditions of gardens and fields. New diagnostic methods allow us to fight with different viruses. Find out more about one of the new developments in this field in our next episodes. Go beyond the limits and discover infinite science with us. Until next time.